This question is from GATE 2015 Mechanical Engineering paper, Set 3, question number 19. Which of the following statements are true for damped vibrations? Statement P. For a system having critical damping, the value of damping ratio is unity and system does not undergo a vibratory motion. Statement Q. Logarithmic decrement method is used to determine the amount of damping in a physical system. Statement R. In case of damping due to dry friction between moving surfaces, resisting force of constant magnitude acts opposite to the relative motion. And statement S. For the case of viscous damping, drag force is directly proportional to the square of relative velocity. So we'll have to analyze each of these statements, PQRS, and see which of these are true and which of them are false, and then mark the correct option. So statement P says that for a critically damped system, damping ratio zeta is 1. Yes, that is true. Damping ratio zeta is defined as damping constant or damping coefficient C of the system divided by its critical damping coefficient. And because this C is equal to Cc, damping ratio becomes 1. And another thing that is given is the system will not have a vibratory motion, which is also true because the response approaches to 0 in very less time. So if the response approaches to 0 as soon as the system is given a external force or initial displacement, it will not have vibratory motion. It is not going to go to and fro, but the response will approach to 0 and the system will be damped for the further time. So statement P is correct. Next statement Q. This says that we can find out damping ratio using logarithmic decrement. Yes, we can do that. There is a relation, logarithmic decrement delta, which is defined as 1 by n. N is number of cycles. Natural log of x naught divided by xn. So these are amplitudes for subsequent cycles. X naught is the amplitude for first cycle and xn is the amplitude for each subsequent cycle at the nth cycle. This is equal to, there is a relation with damping ratio, 2 pi zeta divided by root over 1 minus zeta square. So this ratio shows us that we can find out damping ratio if we know the logarithmic decrement. Hence statement Q is also correct. If we go to statement R, this says that in case of dry friction damping, the damping force is a constant force. The damping force is having a constant magnitude and which acts between the surfaces that are in relative motion. This is also true. The damping force will be a constant force in case of dry friction. As opposed to this, statement S says that drag force is directly proportional to square of the velocity. X dot is the velocity and it is said Fd is directly proportional to square of velocity, which is a wrong statement. Because the correct statement is drag force or the damping force is directly proportional to the velocity itself and not the square of velocity. So Ft actually is given as damping coefficient C into the velocity x dot. And therefore statement S is the wrong statement. So we can see P, Q, R are correct and S is false. Let's mark the correct option. So we have option C correct as S is the only wrong statement in these 4 statements. To learn more about damped vibrations, you can refer to the NPTEL video, Module 2, Lecture 5, L5, Damped Free Vibrations from the course Soil Dynamics. This course is by Dr. Deepankar Chaudhary. He is from Department of Civil Engineering, IIT Bombay. I hope this explanation will help you clear your doubt. Thank you.